Monkey typed in Leetcode. I gotta try another graph problem. Given a node in a connected undirected graph. Given a node in a connected undirected graph, return a deep copy of the graph. Each node in the graph contains an integer value and a list of neighbors. The graph is shown in the test case as an adjacency list. An adjacency list is a map of nodes to lists. Used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. For simplicity, node values are numbered from 1 to n, where n is the total number of nodes. The index of each node within the adjacency list is the same as the node's value, 1 indexed. The input node will always be the first node in the graph and have 1 as the value. There are 3 nodes in the graph. Val equals 1 and neighbors equal 2. Val 2 and neighbors equal 1, 3. Val 3 and neighbors equal 2. Example, with the empty list, you have no nodes connecting to 1, and the graph is empty. You basically want to return the graph. Yeah, so return a deep copy of the graph. I'm going to look at this problem specification on Leetcode. It's probably more informative, slightly possibly. Given a reference of a node in a connected undirected graph, return a deep copy of the graph. Each node in the graph contains a value and a list node of neighbors. Test case format for simplicity, each node's value is one index. For example, val equal 1, the second node will val equal 2, and so on. The graph is represented in the test cases using an adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. Each list represents the set of neighbors of a node in a graph. The given node will always be the first node. You must return a copy of the given node as a reference to a cloned graph. Yeah, there we go. That's the information that I need. So the given node will always be the first node with val equal 1. You must return the copy of the given node as a reference to the cloned graph. Original graph 1, 2, 3, 4 is not equal to, you can't return the same graph 1, 2, 3, 4. The clone looks like this looks like a clone. The nodes are new. Graph looks the same. 1, 2, 3, 4. But the nodes were cloned, but the graph is messed up. Doesn't have the same connections. 1, 3, 2, 4. Fair enough. So 1 is going to be 3 and 4. So 2 and 4. 2 is going to be 1 and 3. 3 is going to be 2 and 4. 4 is going to be 1 and 3. Example 2, empty. Example 3, adjacency. Empty, empty. Yeah. So you return the first node. Just have a think about it. Perhaps you look through this list. The first node in the list, is going to be the node that you return. Return 1. Oh, but the node is in the node format. Think about how you would iterate through to touch all the nodes. You would think, a node, neighbors, you get the node val. Node neighbors though is for neighbor in neighbors. Perhaps self-clone graph node neighbors neighbor. And you'd think that returns some node. And you probably need traverse. As a function that takes in some node. It's like a depth first search. Hmm. Let me think. Could definitely reach an infinite loop. Hmm. Let's do this. None.neighbors. Node.val. Spelled neighbors wrong. Two apostrophes. Hmm. Control O. Oops. Let's remove that.
今天去学校怎么样？
Let's have a look. Adjacency list. Old to new. If node is in old to new, if node in old to new, return the node. Right, if it exists. Don't need to create a new one. So instead of this, No, something else I'm missing. So if node the node itself for node neighbors just keep track of node. You can assert that. Yeah, that's basically it.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem clone graph. So we're given a reference to a node that is in a connected undirected graph, so it's convenient for us that the graph is completely connected. And all we want to do is return a deep copy of that graph, in other words, a clone of that graph. And for every single node, we have two things. We are given a value, and we're also given a list of its neighbors. So this is what's telling us, how the graph happens to be connected. These are the edges in our graph. Now, if you're not super familiar with what a deep copy is, so let's say that this is our example, our input graph. We're not just going to create a shallow copy, meaning like this is the exact same graph, like the color is yellow for both of these, meaning like it's the exact same graph. We didn't actually create a clone of it. So this is not what we're looking for. This is also not what we're looking for. So this is a new graph because the color is slightly different. But you see that the values aren't exactly how they're supposed to be. We have a 3 here, whereas we have a 2 in the original graph, right? So basically we have these 2's values mixed up. So that's not what we want either. We want an exact clone. So it has the exact same structure and values, right? The values and structure is the exact same. And this happens to be a new graph. This is not the exact same graph as this one because this one is blue, whereas this one is yellow. So how are we going to solve this problem? Well, you can see I'm going to use a hash map like pretty much every graph problem, and we're going to use depth first search, where you can also use breadth first search if you want, but let me show you the general algorithm. So you can see these edges are undirected, meaning, if 1 has a neighbor 2, well, 2 is also going to have a neighbor 1 in its neighbor list. So let's say that 1 is our entry point in the graph. What are we going to do? You can see initially our hash map is empty. What we're going to try to do is map the old nodes to the new nodes, or the copy nodes. So we start at 1. So what's the first thing we should do? Well, obviously we should create a copy of this node. That's what I'm going to do. So create a copy of 1. Now this copy of 1 is not complete yet, right? Because take a look at the original one. It has 2 neighbors, 3 and 2. So what can I do? We know we're going to have 2 neighbors for node 1, right? Can I just take these 2 original nodes and then put them over here, 3 and 2? No, I can't do that, because for these nodes 3 and 2, we actually have to create copies of them as well. So you can see that this is going to be recursive. So first thing I'm going to do is I'm going to go to its first neighbor, which let's just say it happens to be 2 in this case, right? So I'm going to start cloning starting at 2. So we're at 2, we're going to create a clone of 2. Oh, and by the way, before I forget, before we make a clone of 2, we know we just created a clone for 1. So what are we going to do? We're going to map the original node 1 to its now clone node 1. So we're mapping the old node to the new node. And I'm going to show you why we're doing that in a second. So now we're going to go to node 2, right? And we're going to create a clone of node 2. So let's create that clone node 2. We're also going to add it to our hash map, right? We're mapping the old node 2 to its clone. So the clone in blue is the new node. So now we've cloned 1 and we've cloned 2. And for 2, now let's look at 2's neighbors. Well, look, you can see that it has a neighbor of 1, right? And it has a neighbor of 4. So first we're going to end up trying to do is create a clone for 2, because we know that we have to, in the list of neighbors for 2, we have to add the clone 1, which we haven't done yet. So what we're going to end up doing is we're going to try to clone 1, but we're going to see in our hash map, look, we already ended up cloning 1. So basically what I'm saying is now we can say, okay, we can add this edge that 2 is connected to 1, that 2 has a neighbor that happens to be 1. And basically the reason I'm doing that is because we know this edge is going to be undirected. It goes both ways. So that's what I'm trying to do here. So now we know that 2 is connected to 1. We also know we have to clone node 4. So now we're going to visit position 4. Let's create a clone for 4. So let's add it to our hash map as well. We're mapping the original node 4 to its clone. So now we're at the node 4. We want to clone 4's neighbors. First, you see that 4 has a neighbor 2, which we already cloned. So we're going to take this original node 4, right? We know the original node 4 has an original neighbor of 2. So then we're going to take that 2, look it up in our hash map, see, okay, we already created a clone of it, and this is the clone. And then we're going to end up taking 4 and connecting it to 2. And let's just say that, when we created the node 4, we ended up connecting 2 to 4. So let's just make this edge go both ways, because we know that originally the edges are undirected. So now that for 4, we wanted to create a clone of 2. We also want to create a clone of its second neighbor, 3. So now let's create a clone of 3. So we know that 4 is going to be able to connect to this neighbor of 3. So we're creating a clone for it. And we're going to take the original 3 node and map it to its new copy node of 3. So now we're almost done, right? You can see that all 4 of the nodes have been copied, but for 3, we haven't added 3's neighbors, right? 3 isn't ended up connecting to any other nodes yet, but we know in the original 3 has 2 neighbors. The first neighbor is 4, so we're going to say, okay, we know that this 4 needs to have a clone, but the good thing is we already created a clone for that node, and this is the clone. So now we have it. So we're going to take 3 and connect it to 4. So we're going to make this edge basically double directed. And 3 also has another neighbor of 1. And so basically what we need to do is make a clone of that one, but we look in our hash map first and we see we already cloned 1. This is the clone. So we're going to take 3 and connect it to 1, right? But wait, we have one last problem, right? This 1 should also be connected to the 3, right? You're right, and that's what we're doing recursively now. So we originally started at 1, then we went to 2, then we went to 4, then we went to 3. Now what we're going to end up doing is reversing that, because we remember we're doing this recursively. So we're going to pop back up to 4. We're going to see 4 has already cloned its neighbors. 3 already cloned its neighbors. We're going to pop back to 2. 2 already cloned its neighbors. We're going to pop back to 1. 1, we ended up cloning the neighbor 2, right? But we didn't end up going this way. So from 3 now, we're going to end up checking, okay, did we already clone 3? Let's look in our hash map. Yep, we already did. So this is the clone that we created. So all we really need to do is make 1 connected to 3. So basically make this edge double directed. So now you can see that we finally created a complete clone of the graph. We did this in O of n time, where n is basically the number of edges plus the number of vertices, right? The number of nodes plus the number of edges connecting them, because we have to basically make a clone of each of these. And with that being said, now let's jump into the code. So we remember that we only need a single data structure, old to new, which is a hash map mapping the old nodes to the new nodes. And I'm going to implement this in depth first search. And you can see that this function is nested in the outer function, which just makes things easier, meaning that this data structure doesn't need to be passed into every single function call, but we do need to pass in every time the node that we're visiting. So in depth first search, we're going to pass in the node. First thing we're going to check is if the node is in our hash map. If it is in our hash map, then that means we already made a clone of it. If we already made a clone of it, then I'm just going to return that clone. We don't need to create another clone. So if it exists, return the new node. So if this statement doesn't execute, that means a clone doesn't already exist. So let's create that clone. I guess I'll call it a copy. So we're going to create a copy of this node. So we're going to use the node constructor, and the value we're going to give it is the value of this original node. And we're also going to take that copy and then add it to our old to new hash map. So old to new. So the old node is just node, and the new node is the copy. So we're mapping the old node to the copy. And then we want to make copies of every single neighbor of the original node. So node.neighbors. Let's go through every single neighbor and let's run depth first search on that neighbor. And so basically, if we run depth first search on that neighbor, what it's going to do is it's going to return the copy that we end up creating. And with that copy, what am I going to do? I'm going to take this old node or this new node, the copy that we made, and I'm going to take its list of neighbors, and I'm going to append to that list of neighbors this the return statement from this depth first search call. So let's copy and paste that in here. So that's all I really need to do, depth first search, and add it to the neighbors of this copy that we just made. And once we're done making all the copies of the neighbors, then we can return the copy that we just made in the current function call. And it's actually that simple, because even though this is called depth first search, it might even be better to call this function clone, because cloning is basically what we're doing. We're taking the original node and creating a clone of that node, and we're cloning all of its neighbors recursively. That's what this recursive call is, right? And then to the neighbors that we're creating, we're adding them or appending them to the list of neighbors of this node. And so it's actually the last thing to do is easier than you would think. We're going to call depth first search, passing in the original node that we're given in the original function call. And then we're just going to return the result of that, because that's going to give us the connected graph. It doesn't really matter which node we return, I think. So any node that we end up returning is good after the entire clone has been made. Oh, and one last thing, we forgot to check one edge case. The original node that we're given could be null. So if the node is non-null, then we're going to call this function return the result. Else, if the node is null, we'll just return null. So with that being said, this function should work. And there you go. It's pretty efficient, even though this indication makes it seem like it's not. I think if I ran it one more time, it would probably be closer to like 50 or 60%. But I hope this was helpful. If you enjoyed, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
While I figure something out, I'm gonna play a bit of music. I gotta do some internship preparation. Just clear out my emails a little bit, I guess. Actually, is it gonna probably already like... No, it's actually alright. Thought it was gonna overlap. I'll click this? Alright, sure. What if I uploaded the incorrect thing? I have no idea. Nah, it's fine. Organize. Okay. I'm gonna play some anime music now. planned for 2 topics. No need to stress or over-prepare. It's meant to be a fun, relaxing conversation to showcase your ideas and creativity. Plus, it's a great opportunity to practice your interview skills. Oh, okay, let me stop this. No written work either, just ready to talk through your approach. Could you please fill out this? If you have any additional questions, please feel free to reply. This is what it is. I'll read through this, but the main thing here is I could either do one of these, so showcase one of your own personal projects. So project brief, you're developing a lightweight collaboration tool. Oh, okay. Core requirements, discussion topics. Oh, right. Discuss the case study attached to get a sense of your approach problem solving. The case study, you can discuss a minimum of 2 topics. So these are the discussion topics, I'm guessing. Yeah, okay. Front-end planning, discussion topic. Alright, so these are all discussion topics. Evaluation criteria, clear ideas on how the user interface will function and the tools you will use. Backend, a clear plan on how the API could work, showcasing problem solving and reasoning. Even if the technologies are unfamiliar, UI and UX, a thoughtful approach to making the app easy and intuitive for users. Interview tips, leverage your past experience. If you can tie your explanations into your past experiences, if you've built something similar before, incorporate examples will make your ideas grounded in reality. Okay, so you're developing a lightweight collaboration tool for managing projects. The tool will be used for project teams to track tasks, discuss projects, progress, and stay organized. The main features should include the ability for users to create projects, assign tasks to team members, track the status of tasks, and leave comments for discussion. Create projects, assign tasks, track the status of tasks, and leave comments. Admins or team leaders should be able to manage team members, oversee projects, and monitor overall progress. Core requirements: members can create projects and tasks, assign tasks and update the task, leave comments on tasks, can manage all projects and tasks, can track overall progress and manage team members. Yeah, tasks should have a title, description, assignee, and status. Admin dashboard shows an overview of all projects and task statuses. Discussion topics, you may choose a maximum of 2 of these. Yeah. And so the front-end planning, the back-end planning. How would you handle real-time updates? What's the task status? So to set up the interface for project creation, task assignment, and commenting. You know, it might be similar to something like Trello. and briefly explain the tools or frameworks you'd use, maybe like React. When you have a task that is used to change on the front end, discussion, how would you design the API to handle creating projects, assign tasks, and updating task statuses? What technologies would you use? That really, for me personally, I would use Fast API. You would need a CRUD of tasks and a CRUD. And for perhaps updating statuses, you could, it'll be updating a task essentially. And the status would be an attribute of the task. A bonus challenge, how would you implement role-based access so that only admins can manage members and track overall progress, while regular users can only manage their own tasks? Well, in the API calls, you might just have to do a check for whether the user that is making the call is in fact, an admin or not. And you can probably get this from the auth token that you use when you are calling the API. Clear ideas on how the interface will function and tools you will choose. A clear plan on how the API could work, showcasing problem-solving reasoning, even if the technologies aren't familiar. A thoughtful approach to making the app easy and intuitive for users. Yeah, okay. So as part of the projects officer, you'll have the option to either discuss the case study or showcase one of your own personal projects and walk us through how you built it and the challenges you faced. I mean, if I go through that, how would I, right? How would I say something, say for like the scheduler app? I'd be thinking, yeah, so this is the app that I'm building, but what would I say? I would say, showcase one of your own personal projects, walk us through how you would build it, how you built it, and the challenges you faced. So how I built it, I followed a template, and this template uses Fast API as the back end with React as the front end, using Vite as the runtime, right? As the tooling, front end tooling. Like, what is Node? Well, no. Okay, yeah. Still Node under the hood, I think. Walk us through how you built it and the challenges you faced. For sure, you know, perhaps take a look at the scheduler app. Log out, log back in. Well, even in the login page, you know, we have a login page. That took time to build. You know, the what I would use to make the login page look nice. And perhaps, you know, we have a forgot password area. It goes to this, which is no CSS. Don't have account, no CSS sign up. But yeah, this is like not bad of a demo to have, I suppose. And you know, following this is quite modular, I guess, you know. Yeah. Not nice that this is like not being rendered properly. Is it specific to the session that I'm in? No. I'll fix it up. I'll fix it up. I'll fix it up eventually. So anyway, we said okay, it hasn't shown up in my inbox. Why is that the case? I would have expected an invite. Perhaps I can try looking at Google Calendar. Yeah, I can't trust it. That's what it's like. I don't like Google sending notifications like that. Okay, well, it seems to me that this doesn't show up, which means I gotta be proactive here. Make sure I keep remember this. Okay, we'll add it into events. Accept. Okay, fine. Now, important stuff. KFC says, what languages have you used for making the open source app? Oh yeah. I mean, I said it before, but React, so I mean that will just be TypeScript, Python, using Fast API. Those are the two main languages. Everything else is just supplementary, I guess. But Sammy, good morning. Good morning to you. You know, for me, it's in the afternoon now. So I watched the pre-shoot. Need to send an email to them. Did the tutorial. Did the lecture. Did the lunch. Did the lecture. CS tutorial is also done. Baseline code is kind of what I needed to get on. I should do at least one, right? Surely. At least one is ideally what I'd like. And I'll send this email now. After I find exactly A2 marks, individual, nope. Where is it? Consultation, group wiki, and self-reflection. Oh, here we go. Okay. Oops. A3 preliminary. I'll just put my name. Kahoo. Kayeg. Nice, palindrome. Is that right? Kayeg. At okay. Yeah. This is for planning. This is for the grade in 2 out of 5. So student failed to mention any of this. Q may need to specify the state space, initial space. Concerns with design decision criteria. For assignment, this follows on from my direct communication with design decision criteria. This follows on from my direct communication with EA. Where I stated that perhaps there was ambiguity in what designs meant I was under the assumption that designs referred to mainly the implementation of code, but I wrote a lot about that, but my marker was looking for a more detailed explanation on the design choices of the Q learning concept itself. I've attached the exact comment. And maybe I can quote this. I have concerns with with specifically the design decision criteria. The criterion, I think that's fine. So this follows from my direct communication with Gay, where I stated that perhaps there was ambiguity in the design, in what designs meant to the student and to the marker. I was under the assumption that designs referred to mainly the implementation of code. So I wrote a lot about that, but my marker was looking for a more detailed explanation on the design choices of the Q learning concept itself, such as number of iterations the transition function, etc. I've attached the exact comment below, exact marker comment below. If you're using Q-learning, you may need to specify the state space, initial state, and reward functions in more details. So it looked like I understood the comment, but zero marks for design decision seems a little unfair. But I mean, what I want to, you know, still have a positive tone to this. It's not like I'm complaining. Understand the comment. I understand the concern raised by the marker, but 0 marks for design decisions here seems a little unfair. Can I just run it through ChatGPT to make it in a positive tone? Write the above sentence in a positive tone. Though I feel no marks for the design seemed a little bit unexpected. Yeah, man. Thanks, ChatGPT. Okay, so I appreciate the concerns raised by the marker. Though I feel no marks for the design decision seemed a little bit unexpected. Alright, I mean, that's fine. That's fine. It's not really that big of a deal. Alright, A3 preliminary feedback. I guess I'll just say feedback and put my name at the end of it. No, don't include feedback. That's alright, done. It's off. Oh, does it send? Yes, it does. Sent. Yeah, it's sent. I didn't even say hi, hello. I didn't even. I'm sorry. I'm sorry. That kind of was a bit hasty. But that's it. User says Yaru bro. I don't know. Is that is that it? I don't know. I'm not gonna say. But I will search it. Okay, it is Tamil, I think. What do you mean, bro? And is that actually? Okay. All right, now we can focus on baseline code. Oh, yeah, I wanted to write specifications. So this is the final thing. Coming from TV. What's Siri? Sorry, from APA. And this is gonna be, let me turn on lights. The reward function takes a state, action, and new state. Where the new state is the state after performing the action, performing an action, performing action on state. Theoretically, including this new state variable is unnecessary since it can be derived solely from state and action. However, it's included here to minimize recomputation. Recomputation is not a word. To minimize recomputing the new state. Preview. Oh, here we go. And returns the new state is the state after performing action on state. Okay, so the reward function takes a state, action, and new state and returns the numeric reward. So this is the immediate reward. The new state is the state after performing action on state. Theoretically, including the new state variable is unnecessary since it can be derived solely from state and action. However, it's included here to minimize recomputing the new state. But it's borderline nonsensical. So I've put a link directly to it. Now I should probably highlight exactly where this is and copy permalink. And then I'll just update this. Okay, right, line 23 to 29, okay. Preview. Right click. Yeah, we get exactly that. And we can update that comment. All right. Implement get rewards. Change branch source. To initialize my understanding. Implement get rewards. I'll just create the branch. When coding use the created branch for this PR. Oh, wait, I should have just saved what that said. You can switch to that branch. So requirement. Yeah, I mean, I see this as no problem. I think that's pretty straightforward to understand, I hope. And finally, the other issue, get transitions. Okay, so if I put it out one level, out one level, just one. Okay. Git fetch origin, I guess, yeah. So I'm looking at this get transitions. The choice is not left up to the environment and is instead determined by another agent. Alright, so in multi-agent MCTS, Mutley, which is the case for Azul, the choice is not left up to the environment, but is instead determined by another agent. Q learning agent, Maybe. See more detailed description of the problem here, if needed. When coding, use the created branch for this PR. You can switch to that branch with okay, well, how does that doesn't mean anything. So so just the definition, the get transitions function takes, how does that look? The get transitions hops takes as input the state and action to perform. Is it? Get transitions performs, so get transitions, state and action. This state, is it the state after performing the action or is it the state before? I'm guessing it's before. So reward, return the reward. Wait, return all non-zero probability transitions for this action from this state. Yeah, as a list of state probability pairs. Okay. For some background. Am I authorized to say that? No. Yeah, from some, for some background from my reading. On Tim Miller's guide. You know, maybe I'll link this now. Tim Miller's. don't think I replied, did I? No, I did. Eee. From my readings on Tim Miller's reinforcement learning notes, okay, I mean, this is can I copy and paste this whole thing? I really wonder. Nope. I'll just copy this, paste it into this. Whoops. Need to copy perhaps this whole thing. Can I do this? I can. However, in multi-agent MCTS, which is the case for Azul, the choice is not left up to the environment, but is instead determined by another agent. So perhaps should you model this as a single agent MCTS first? Alright, anyway, I think that's pretty explicit. Although, you know, maybe, is there an explanation on the reward function? In online planning, we need to access to a simulator that approximates the transition functions of our MDP. A model can be used, however, often it is easier to write a simulation that can choose outcomes with probability, that is to analytically calculate the probabilities for any state. For example, consider games like StarCraft. Calculating the probability of ending in a state for a given action is more difficult than simulating possible states. Then it is to analytically calculate the probabilities. The simulator allows us to run repeated simulations of possible futures to gain an idea of what moves are likely to be good moves compared to others. The question is, how do we do the repeated simulations? Monte Carlo methods are by far the most widely used approach. Okay, interesting. Given the reward R as the terminating state, backpropagate the reward to calculate the value Vs at each state along the path. Where is reward ever mentioned? Okay. What else is there? It's the Q Yeah, I also wanted to say the forward. Maybe I'll just paste the code. No. Nah, man. It's probably a little much. It's probably overwhelming. Nah, man, just don't include it. I think it's probably best. Okay. I can send this off now. Discord. What's happening? This is newcomers. Okay. Maybe I need a mute channel. Does this also reflect notification settings? Newcomers, yes. Okay. I've said a lot. Alright. Perhaps I am addicted to Leetcode. Which keyboard do I use? As in, like, right now, which keyboard do I use, or... No, I'm kidding. This keyboard, is called the Glove 80. I've linked it in the description. Alright, so do I want to do a hard question? Or a heap question? I'm going to do a heap question. Given an unsorted array of integers nums and an integer k, return the kth largest element in the array. By the kth largest element, we mean the kth largest element in the sorted order, not the kth distinct element. Can you solve it without sorting? Oh. I mean... Okay. I mean, this is just basically to use heap queue. This is basically telling us to use heap queue. I mean, sorting is n log n. I can do log n. Ooh, is heapify log n? I have to have written this down. I have to have. Okay. It's O of n. Alright, so if you do this in O of n, and then you do heap pop multiple times, you get log n. At the end of the day, it's still... Okay, it's n k log n. Is it? N k log n? No, that can't be it. Tusha, where are you from? I'm from Australia. It's dark out now. It's not going to be n log n, right? It's not going to be nk log n because it's not n log n. It's O of n to heapify plus k log n. N plus k log n. is how much it's going to take. Which is less than n log n? Yes, it is. All right, but it's n plus k log n, I think. But if you were to do this normally, just sorting the numbers, you know, you might think sorted of nums and perhaps like for while k is not equal to 0 or k is greater than 1, Dad's telling me to eat. I'll be in a moment, I think. This is popping, yeah, from the right. And you're sorting in ascending order, so you're popping from the right. Otherwise, you know, if there's nothing in there, you would return, I'm guessing, yeah, oh no, it has to have something in there. Okay. Now this would work, but, you know, you can submit this, and that would work. However, you might want to make it more efficient. So, you know, this is a create a new page. What's this called again? So kth largest element in an array. Problem easily solvable in but it is also solvable in n plus k log n. Yep. Using a heap. So n log n, so is that n k log n? No, it's just n log n plus k, technically. Alright, I gotta eat. Alright, so I'll eat, but I'll finish this problem after I eat. Okay, BRB. Okay. I'm gonna just do this Leetcode question in actually wait, let me copy this. Just paste it here. Yikes, that looks bad. Okay. Python. But we want instead so this is going to be maximum for n in nums, so we can get max heap q. You heap up a number of times if so while k is not equal to 0, okay. Okay, sure. Okay. So forgot that, but yeah, that's as simple as it gets. As simple as it gets.
everyone, welcome back.
How could this... Okay. This is an 18-minute question. Fine, we'll watch it.
And let's write some more neat code today. So today let's solve the problem kth largest element in an array. So we're given an integer array nums and an integer k. We want to return the kth largest element in the array. By largest, they mean largest in sorted order, not the largest distinct element. So we could have duplicates in this array. And so when they say, let's say k equals...
Oh, in sorted order.
1, right? If k was 1 and let's say this array was sorted, then that would mean we want the rightmost element because we want the first largest element. If k is 2, we want the second largest.
I'm gonna open this new tab.
Largest element. So not the largest element, but the second largest element. So that's how it works. Now, the most obvious solution you probably could already come up with by yourself is just take the input array. It's not necessarily going to be sorted, but we could sort it ourselves. What would be the time complexity? Well, it would be n log n, right? That's the time complexity to sort. And since this is an array, once we sort it, we can instantly check the index that we want. What index are we going to want? Let's say k is 2. What index would we want in nums? We'd want the second largest, right? So instead of the largest, we'd want the second largest. So how would we do that? We'd just take the length of the array minus k. That would give us the index that we want to get to. But this is a medium problem, so you can assume that there are going to be different solutions. Can we do better than n log n? Well, it turns out we can, and one solution is using a max heap. Using a heap will be slightly better because we won't have to sort the entire input array. What we can do with a heap is you can take an entire input array like this one and you can heapify it. You can turn it into a heap, and you can do that in O of n time. But just because we have a heap doesn't mean we've necessarily solved the problem, because we don't necessarily want the largest element in the array. We might want the kth largest element. So from that heap, after we've already done an n operation to turn this array into a heap, then we're going to have to pop from that heap k times, because it's a max heap. So we're going to pop k times so we can get the kth largest element. Every time you pop from a heap, it takes a log n operation where n's the size of the heap. How many times are we going to pop? We're going to pop k times because we want the kth largest. So this is the time complexity of the heap solution. You can see it's slightly better than n log n depending on whatever k happens to be. So in some cases, it will be better than the sorting approach if k is relatively small. And that's about as good as you can do in terms of worst case time.
Okay, interesting. Because the question is, if I run this problem on Leetcode, are you telling me that it won't pass? I mean, it's accepted.
Complexity, but there is a solution that's better actually if you want to know the average case time complexity. And that's what I'm going to be focusing on, because that's, I think, the more difficult of the three solutions that I've talked about. So this third solution actually can be achieved with O of n average time complexity, not worst case. The worst case actually happens to be n squared. So in the worst case, it's not that efficient, but in the average case, it is pretty efficient. What
I think you should use the correct notation, not
algorithm
just
am I talking about? Well, I'm talking about the algorithm quick select. It's pretty similar to a standard algorithm that you may know called quick sort. And if you haven't heard of this algorithm, I'm going to be teaching it to you today. If you have, then you can probably implement this yourself. Let me show you how to do that now. So let's take a look at this first example. And like I said, this algorithm is going to be really similar to quick sort. And the main part about quicksort is the partition. So that's what we're going to do first. We're going to take this entire array and partition it into two halves, right? We're going to somewhat cut it in half. One half of the array is going to be every value in, let's say this half of the array is less than or equal to every value in the right half of the array. That's how we're going to partition it. So how can we make sure that it's always going to be half? Well, it turns out we can't. That's why the worst case time complexity is going to be n squared, and the average case time complexity is going to be O of n. Because what we're going to do is we're going to randomly pick a pivot. Let's just pick the rightmost element each time as the pivot value. When I say pivot, I mean this value is going to decide what goes in the left half and what goes in the right half. So what we're going to do now, we selected this as our pivot. We're going to start at the beginning of the array, and we're going to go through each element and we're going to compare each element to this pivot value. So for example, 3 is less than or equal to 4, right? So what are we going to do? We're going to make sure to place it in the left half of the array. It's already in this spot, so what we're going to do is basically just swap it with itself, and then we're going to shift our pivot pointer over here. This pointer is basically going to indicate every time we find a value such as this one or this one that's less than or equal to 4, then we can put it in this spot wherever this pointer happens to be. And then once we've done that, we're going to take this pointer and shift it again to indicate that, okay, next time we find a value like this one that's less than or equal to 4, then we're going to put the value in this position. So in the actual code, we're going to be doing this in place, but I just drew an extra piece of memory just to kind of help you visualize it. So we're going to take our 3, keep it in this spot. 3 is going to go here. Our P pointer is now going to be shifted here.
Bruh. Alright. Here's the thing. I don't think I need this right now. Yeah, I'm not going to be, it's not really worth watching this part, but I'll watch it on my next Leetcode problem. So before I start my next Leetcode problem, this is going to be the one that I gotta watch. Just remember that. Okay. And alright, we're good. We're gonna call it a day. Call it the end of the stream. And to the 2 people in this chat, thank you for watching. And yeah, probably tomorrow gonna be online. See yous.